All right, we're going over right now section 2.1b, and we're looking at where the mean versus the median is located on a density curve. The first thing you need in your notes is you need to know the definition of a density curve. And a density curve is an overall pattern of a large number of observations described by a smooth curve. So pause the video right now so you can write down this definition. I'm going to start up again here in a second. Okay. So, like I said, a density curve is an overall pattern of a large number of observations described by a smooth curve. So what I have right here is I have 3 different density curves. Forgive me for that. Okay, so we're going to keep going on. We have 3 different density curves here, and you can have a bunch of different density curves. What it is doing, it is modeling, if there were so many observations going on, what that's looking like. So you can imagine there's many dots that are under these curves. So there's a peak right here, and then all the dots, if it was a big dot plot, are going down. This one is my attempt, and I did it fast, of a skewed right observation, and here's a skewed left distribution, excuse me. So now for purposes of learning today, what I need you guys to take n equals 18, so 18 observations, and I need you to make a dot plot under these curves. So forgive me because I didn't mention it before, if you made them really small, you may need to redraw your density curves, but I'll show you on the next page what I have. Again, I know a large number of observations is not 18, but for purposes of learning, we need to do this. So what I went ahead and did is I made my own dot plot that modeled the density curves that are symmetric, skewed left, and skewed right, and each one of them have 18 observations, okay? Now, in order to estimate the median, what I need to do is know, well, what is the median? Those of you who have taken calculus, you should hopefully truly understand this as the area under the curve. The median is the place that separates, or separates the equal areas under the curve. It's the point at which the equal, excuse me, I'm fumbling over my words. The median is the equal area point. So if I drew a line right here, the area under the curve, and let me do it and then I'll hit undo, is larger on this side than it is on this side. It is not the equal area point. Again, this is all calculus. Now, some of you have not taken calculus, so I don't want to scare you away. That's why I had you draw the x's under the curve. You can think of this equal area point as the x's. The number of x's need to be approximately equal. What do I mean by that? Well, I have 18 x's. That means there's 18 observations. I know then that 18 divided by 2 is going to give me 9. That means the median is the 9th observation. So moving from left to right, because it's a number line, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. My median is here, so I'm going to draw a line. This is the median, the equal area point. Again, for those of you who took calculus, you know that this area under the curve then should be equal to this area under the curve. If the calculus doesn't resonate with you, that's fine. Just make sure that you understand that 18 divided by 2 gives you the 9th observation. That's the median point. So again, I can do it over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? That, I'm going to draw my line right here. This is the median, the equal area point. And you can almost imagine if I took these x's right here and put them on top there, it would look like equal area point in terms of calculus. Again, if that doesn't resonate with you, no problem. Just remember the 9th observation. And again, I'm going to do it over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the median is approximately here. Well, now we need to know how to estimate the mean. When we estimate the mean is the balance point. The best way I can describe that to you is to imagine that we had weights, okay? Doesn't matter what, 5-pound weights, doesn't matter. We had weights going across this black line. At what point am I going to put the fulcrum, for those of you who have taken physics? If you haven't taken physics, it's like it's a seesaw. This black line here is a seesaw, and I have 1, 2, 3, 4 people on this side and 4 people on this side. Where can I make it so it's balanced? Well, I already answered the question. If I put my fulcrum, my little triangle there, I have 1 circle, 2 circles, 3 circles, 4 circles. 1, 2, 3, 4 weights, or 4 people, if you want to think of it like a seesaw. I have 4 people on this side. That's the balance point. So that makes sense. With a symmetric distribution, the mean is equal to the median. Now let's look over here. Again, on this black line here, I'm not going to worry about how high it goes up. I'm just worrying about my beginning point and my end point. I'm going to make little circles, imagining they're little people sitting on a seesaw. I have 1, 2, 3, 4, 5, 6, 7, 8. Where are they going to be on a seesaw where it's going to be exactly equal? No one's going to be tilting one way or another. 1, 2, 3, 4. 1, 2, 3, 4. So 1, 2, 3, 4. 1, 2, 3, 4. Right here. I'm going to put that fulcrum so it's equally weighted on both sides. The balance point. So my mean is going to go right here. Again, why? You can think of it as the mean chasing the tail as well. And finally, we look over here. Again, I'm going to look at this black line right here. Now I just turned it to yellow. I don't care how high it goes up. I just care about my beginning point and my end point. I'm going to make some people. They're all sitting on the seesaw. Okay, I'm going to count. How many people do I have on the seesaw? 1, 2, 3, 4, 5, 6, 7, 8, 9 now. Where am I going to have an equal, so there's no tipping going on that seesaw. Where am I going to put that fulcrum? Well, there's 9, so I'm going to have to go to a half of a person. 1, 2, 3, 1, 2, 3, 4 people. 1, 2, 3, 4 people. So this person is going to sit right in the middle of that fulcrum, that halfway mark. And this is where the mean is located. Okay, let's just quick sum things up. I talked a little bit about calculus. If you don't remember calculus, don't worry. Or you don't understand calculus, don't worry. All you need to do is you need to think about your density curve. I'll redraw over it right now. You can even draw in x's if you want, just like we did. You can count how many x's you have. Divide it by 2. This gives you the median observation. Count from left to right to figure out where that observation is. That's where the median goes. Next, to find the average, you imagine that you have a seesaw. You have people lined up across the seesaw. Where is it going to balance out? If I put the balance over here, it's going to tip. It's going to lean, okay? Where is it going to lean? It's going to lean down because all the weight's on this side. I need the balance point right here, right in the middle. There's 4 people on the left. There's 4 people on the right. It's balanced. This is how we figure out where the mean versus the median is for each curve, okay? If you have any questions, write them down. Hopefully this made sense, and I know it's a lot of videos today, but thanks for being patient, getting everything down, and I will be